of the biggest challenges in dealing with a site like this is it's a very skinny site. It had a lot of utilities that were running underneath the roadway that had to be relocated before we even started. It started out as a 9,000 square foot building, approximately $9 million for the project. And during the programming phase, it became evident that it was not large enough to house all the functions that the streetcar required.
GLHN's had an active involvement in downtown development for our 50-year history. We're an integrated architectural engineering firm. We've got mechanical, electrical, civil, architects, technology guys, commissioning guys. We've got a whole menu of experts, and this building type gave us the opportunity to have all of us collaborate together in a really unique project.
The design process for the building was to looking at historic type of forms for a rail facility. And not just looking in Tucson, but also looking around the country. And the barrel vault structural system is used a lot in railway systems. So we wanted to reflect that in a new facility here in Tucson. And so what you're going to see is that the maintenance facility, the actual maintenance bays, utilize basically a partial barrel vault and a full barrel vault, with clear stories wrapping those so that you get good light.
There's a pit underneath to work on the bottom of the cars. There's a mezzanine above to work on the top of the cars.
There's a crane that actually allows things to be picked up from where they're delivered, takes them up to the mezzanine, drops them off.
There's actually a turntable to allow you to swivel the trucks completely 360 degrees. Again, like my model train set. It's got all of the good stuff that you'd expect in a rail facility. So one of the aspects of this was figuring out how to get the wires from outside the facility to inside the facility so you could actually drive the streetcar in to be worked on.
We used a bifold door and placed a gap, basically a square up at the top corner of one of the doors. That allows the OCS to maintain continuity right into the building. These things are 20 feet tall, high pressure stainless steel bearings for the hinges, and they operate flawlessly.
So another part of this thing that was really tricky at the interface was getting the tracks to line up. The streetcar tracks outside by the outside streetcar track contractor had to line up with the inside tracks by the building contractor exactly. And getting that laid out in advance, figuring out the geometry of how that would work was a really critical aspect of the civil engineering. Along with that is the need that the yard out here is dead level. So getting the grades right here was a tricky part of the site work, civil engineering, and coordination, collaboration among a whole lot of different design firms, contracting firms, and ultimately the project team. In terms of sort of global sustainability, this is the kind of thing that needs to happen. This is a much more efficient way for communities to interact in a dense urban core with an efficient transit system and not individual cars driving to houses out in the suburbs. So I think we're really sort of setting the stage as the future comes to us here. We're developing what we're going to need to be able to sustain into the next 100 years.
Really reflects more of the modern era, the fact that this is a facility that wants to look historic. It's in a historic area, but it's also a very modern facility for a very modern streetcar.